When you get a multiple choice question like this, where you're given a reagent, a substrate, and conditions, and you're asked to choose the major product, go step by step. First, consider the reagent, which is methoxide. Then consider the conditions, two things, the solvent and the temperature. And so that's the second thing you look at. The third thing, look at the substrate and just make sure it's reasonable. This is your substrate. Okay, so let's go step by step. So our reagent is methoxide. That's an alkoxide, both a strong base and a strong nucleophile. Strong base gives you E2 mechanism. Strong nucleophile gives you SN2. So, which of these mechanisms will we favor? Now we have to look at the conditions. Okay, first of all, the solvent, methanol. Protic solvents do not favor SN2. Right? If we wanted to get this to go SN2, we would use a polar aprotic solvent. And the second thing is the temperature. Heat favors elimination, and the delta symbolizes heat. So that means SN2 is likely based on the reagent and the conditions. Now we look at the substrate, which is a primary alkyl halide, a secondary alkyl halide, which is reasonable to undergo both SN2 and E2. Okay, another thing we need to consider now is regio and stereochemistry. Regiochemistry, our base, methoxide, is not sterically hindered, so it's going to give us the Zaitsev product, which means there's only one beta proton that we can eliminate, and that's here. Okay? And when you have only one beta proton, your reaction is going to be stereospecific. Okay? Because the beta proton has to be anti-periplanar to the leaving group. And right now, our beta proton is not anti-periplanar. In fact, it has a 60-degree dihedral angle to the leaving group. So we need to do a rotation around this carbon to bring the methyl group to the down position and put the bromide on the dash. So here's the rotamer we're actually going to go through. Leaving that top carbon alone, but now the bottom carbon we have rotated. Okay, now our methoxide can come in and do proton transfer on that beta proton. That pair of electrons becomes the pi bond, and the leaving group leaves, which leads to only the Z stereoisomer.